Hello everybody, and welcome back to another episode of HaugoMATH video. In this episode, I'm gonna meet a new friend as we learn a little bit about linear relationships. Enjoy! Well, I was told this was supposed to be a fishing expedition, but I'm not so sure now. The guy said they had to pick up something first. I wonder what that's gonna be. Yeah, definitely not a fishing trip. Whoa, King Kong? What are they planning on doing with him? He looks bored. I'm gonna go talk to him. Hey buddy, what are you doing? I feel bad that they stole you away from your homeland. Well, what do you want to talk about? Slope-intercept form equations? Sweet! Well, slope-intercept form equations are equations that represent linear situations. Situations that produce a constant increase or decrease. Want an example? So you like bananas, right? Well, let's pretend you already ate 500 bananas and now you're going to eat 100 more each minute. This would be a linear situation because the total amount of bananas you eat will always go up by 100 for every additional minute. So to determine the total bananas you've eaten, we would need to multiply the 100 with the number of minutes and add it to the 500 bananas that you've already eaten. This is a linear equation. And linear equations follow a form of y equals mx plus b, which we call slope-intercept form, with a slope and intercept, a y-intercept, being important to the equation. These letters are all placeholders for information. The y is for the y variable, in our case, total bananas eaten. The m is the placeholder for the slope number, which explains how much up or down we continually go. For us, 100. The x is where we place the other variable, the x variable, in our case, minutes, and the b is where the y-intercept goes, which is also known as the starting value. In our situation, the 500 bananas you already ate. You see how this fits the y equals mx plus b form? We have repetitive adding of 100, and multiplication allows us to do this repetitive adding quickly. So that is why we take the slope number of 100 and multiply it by the number of minutes. And then we add this to what you would have already eaten, 500, the y-intercept or starting number. The graph would look like this. It starts at 500 and goes up by 100 each minute, which would produce a line. That's why we call it linear. The slope determines how much up the line goes for every 1 unit of measurement, in our case, minutes. 100 bananas per 1 minute. And the y-intercept shows us where to start the line on the y-axis. Pretty cool, huh, Kong? Hey, you're in New York. Wonder what they're planning on doing with you. This can't be good. My guess is whatever they're planning on doing with you, you're not going to like it. I'm not going to stand for this. When we stop, I'm going to set you free, big fella. Let's go for a walk and I'll teach you more about linear relationships. Yeah, I thought you'd like that. Wow. Downtown New York at night is so pretty. Maybe we can find some situations here that would produce a linear relationship.
Hey, you on that monkey's shoulder! Get down from there!
He's not a monkey. He's a gorilla, and he really dislikes being called a monkey. I call him Gorilla, or by his name, Kong.
Nobody move! We're taking this monkey back to his captors!
I told them not to call you a monkey. That's their mistake. Great idea, Kong. They can't get us here on top of the Empire State Building. Wow, you're a fast climber. We're already 30 floors up. And now, 5 seconds later, we're 90 floors up. And considering you climbed at a constant rate, we have ourselves a linear relationship. And the graph would look like this, a straight line. Your y-intercept would be 30 because at the start of my counting, we were 30 floors up. But the slope, how many floors you climb per second, would need to be calculated. We do know that we went from the 30th floor up to the 90th floor in the time I measured. That's 60 floors in 5 seconds. Most people use a procedure of dividing the rise, or up movement, by the run, or over movement, between 2 points to obtain the slope. Here our rise is 60 floors, and the run is 5 seconds. This divides out to be 12 floors per second. That's our slope number. This is the repetitive increase that makes the graph be a line. Now an equation can be written. To find the number of floors scaled, we'll take the slope of 12 and multiply it by the number of seconds that go by and add that to the 30 floors that were already climbed, which is the y-intercept. Now we can use the equation to answer questions we might have, such as, how many total floors will we have climbed in 3 seconds? Well, we'll just replace the seconds variable with the number 3, multiply that with the slope number 12, because we go 12 floors up every second, and now add it to the 30 floors we started from, and that makes for 66. We would have been at the 66th floor after 3 seconds of climbing from our starting point. We could also figure out how long it would take us to reach the top of the Empire State Building. The building itself is 102 floors high. This time we will plug in 102 as the floor number we are trying to get our equation to total. But we have to figure out the number of seconds of climbing that will make this happen. Here we need to solve the equation. Let's take away 30 on both sides, which simplifies our solving to having to figure out how many seconds it takes to go that additional 72 floors from where we started. Divide the 72 by 12, and we find out that it would take 6 seconds to make it to the top from where we started. Why do I feel like a giant gorilla on top of the Empire State Building isn't a good idea? I almost feel like there may have been a movie similar to this situation. Maybe not. That doesn't seem realistic. Well, either way, we should probably get down. Wow, Kong, you brought a parachute? Well, that's convenient. Let's jump down so I can hide you in my basement away from your captors, and maybe we can play some video games or something. I have the perfect one in mind. Hey, you know, this parachute drop is another linear situation, although it's a decreasing one this time. We are falling 6 floors per second, which again would make a straight line graph, but this time the graph is going down. So an equation to represent this would be, to find the floor number we would be at, take the 102 floors and subtract 6 floors times the number of seconds of falling. So here we have a negative slope, -6, because we repetitively take away 6 more floors every second. The equation can be written this way as F equals -6s plus 102, which would produce the same line, but this way would match the y equals MX+B form. But either way is fine. Let's take a look at that rise over run method one more time to show the slope for this example. If we choose the starting point and 760, that makes for a rise of -42 because we're going down, and a run of 7, which divides out to make that slope of -6. Alright, Kong, let's get you back to my place so you can hide. Yeah, you look tired. Well, you can take a nap when we get there. All right, Kong, your turn. Hey, it's your turn.